Welcome to Creata Classes. In this lecture, we will cover the distance between incenter and the circumcenter. Incenter we know is the intersection point of three angle bisector, and the circumcenter is the intersection point of three perpendicular bisector. In this lecture, we will find the distance between incenter and the circumcenter. For that, let's take a triangle ABC. This is the triangle ABC. First of all, we will try to find the incenter and the circumcenter inside this triangle ABC. The proof or the approach to the formula is slightly tricky and slightly complex. But with the help of animation and visual tool, I will try to make it easy for you. Let's see. Firstly, we will go with incenter. For that, let's draw the three angle bisectors. The intersection point of these three angle bisector is the incenter. That is, this point I is the incenter for this triangle ABC. For the time being, we are deleting the angle bisectors so to avoid any clumsiness. Here we are just concerned with the point I. From this point I, that is the incenter, we can form an incircle. This is the incircle with the radius as small r. And in the lecture of angle bisectors, we have seen that the radius makes an angle of 90 degree with the sides of the triangle. These sides of triangle act as a tangent to the circle. So the sides of the triangle and the radius make an angle of 90 degree. For the time being, we are removing in circle and in radius. We will bring it back as needed. Just note that in radius and side of the triangle makes angle of 90 degree. We will use it later on. For the time being, we are deleting it. Further, let's try to find the circumcenter for this triangle. For that, let's draw the three perpendicular bisectors. These are the three perpendicular bisectors for this triangle ABC. And the intersection point of these three perpendicular bisectors is the circumcenter, that is the point O. Here this point O is the circumcenter. For the time being, we are deleting these three perpendicular bisectors so to avoid any clumsiness. Okay, we are here concerned with only the point O, that is the circumcenter. Further, with this circumcenter as the center, we can draw a circle which is touching the three vertex of the triangle. This circle is the circumcircle. And we know the radius of the circumcircle we have denoted as capital R. So this distance or this radius will be capital R. In this lecture, we have to find the distance between the incenter and the circumcenter. That is, we have to find the distance between point I and point O. That is this distance. Let's denote this distance as D. So we have to find the value of D. Moving further, let's extend this line IO so that it will touch the boundary of the circle. That is the circumference of this circle. We got 2 points on the circumcircle, that are X and Y. Further, let's join the point A and I. And we will extend this line to meet the circle at point M. We got the line segment AM. And also we got the line segment XY. Can we say these two line segments as the chords of the circle? Diameter is also the chord. So we can say AM and XY are the two chords of the circle which are intersecting at the point I. If we apply the intersecting chord theorem, that is, the products of the length of the line segments on each chord are equal. As per this theorem, if we are having two chords inside the circle and these chords are intersecting each other, then these chords will be forming 4 segments. And as per this theorem, the product of the segment of the chord are equal to each other. Means if we take a circle with the chords as AD and BC, then the product of the segment means AP into PD will be equal to CP into PB. This is intersecting chord theorem. We are not going into the detail of the theorem, just you should know that the product of the segment of the intersecting chords are equal. So here in our case, we are having two chords as XY and AM Okay, and these chords are intersecting at point I. So these chords are forming four segments, that is xi, iy, ai and im. And as per this theorem, the product of these segments will be equal. That is ai into im is equal to xi into iy. Got it? This is intersecting chord theorem. Moving further, this is circumcircle and the center of the circumcircle is point O. So can we denote this line segment OY as capital R, that is the radius of the circumcircle? And also OX is also equal to capital R, that is also the radius of the circle. So can we replace XI with R minus G and IY as R plus G? This length is R, so XI will be equal to R minus D. And this length will be equal to R plus D. Got it? So we got our equation as AI into IM is equal to R minus G into R plus G. Moving further, let's join BM. If we observe only the circle, the line segment BM, BC, AM and AC, can we say angle MAC is equal to angle MBC? These two angles are subtended by the arc MC at point A and B. These angles are coming in the same segment of circle, so these angles will be equal to each other. We have applied the fundamentals of the circles. Let's give the name to both of these angles as angle theta. So both of these angles will be angle theta. Moving further, here I is the incenter. So can we say the line segment AI is the angle bisector? Incenter is the point of intersection of three angle bisectors. So we can say the line segment AI is the angle bisector. Means both of these angles will be equal to each other. So we got both of these angles as equal to angle theta. So in this figure, we can say these three angles are equal to angle theta. That is, these three angles are equal to each other. In the similar line, can we join the point B with point I? And this line segment will also be the angle bisector. It is joining with the incenter, so the line segment BI will be the angle bisector. Got it? If this line segment BI is the angle bisector, means both of these angles will be equal to each other. For simplicity, let's denote both of these angles as angle X. Further, if you observe the triangle AIB, this triangle, here this angle is angle theta, this angle is angle X. So can we say this angle as the exterior angle for this triangle? And we know the exterior angle of the triangle is equal to the sum of two opposite interior angle of the triangle. Means this angle will be equal to sum of these two angles. Means this angle will be equal to theta plus X. Got it? We have applied the exterior angle property of the triangle. That is, exterior angle is equal to the sum of two opposite interior angles. Further, if we observe the triangle BIM, this small triangle, here this angle is angle theta plus X, and can we say this angle is also theta plus X? So we got both of these angles are equal in this triangle. And we know the side opposite to equal angles in a triangle are equal. Means both of these sides will be equal to each other. Why these are equal? Because these two angles are equal. And we know the side opposite to equal angles in a triangle are equal. So we got this triangle as an isosceles triangle with the side BM is equal to side IM. So let's replace IM with BM in our equation. We got AI into BM is equal to R minus D into R plus D. Got it? The figure is becoming slightly clumsy, but with the help of animation and the visual tools, I will try to make the concept very clear to you. If you are getting any confusion, you can pause and repeat the video. It will help you. Moving further, let's join the point M with point O. O is the circumcenter. So this line segment will be the radius of the circle. We can say so. Let's denote OM as capital R, that is the circumradius. Further, let's extend the line segment MO to the point N that is on the boundary of the circle. So we got the line segment MN. Here MO is the capital R, that is the radius, and ON is also equal to capital R, that is the radius of the circle, that is circumradius. Further, let's join the point B and N. For the time being, to avoid any clumsiness, let's hide the other lines. Here, are you able to observe the arc BM is subtending the angle at point A and point N? Both of these angles are coming in the same segment of circle, so these angles will be equal to each other. Angle BAM is angle theta, so this angle, that is BNM, is also equal to angle theta. Got it? These two angles are the angles subtended by the arc BM at point A and point N. So we got both of these angles will be equal to each other. Got it? Moving further, here this line segment MN is the diameter of the circumcircle. And this diameter is subtending the angle at point B. And we know the angle subtended by the diameter at any point on the circumference of the circle is a 90-degree angle. Means this angle will be equal to 90 degree. We have applied the fundamental of the circles. Moving further, in the starting of the lecture, we have discussed about the incircle and inradius. And we have also seen the radius of the incircle is perpendicular to the sides of the triangle. Let's give name to this point as point L. So IL will be the inradius, that is small r. And this angle will be 90-degree angle. Moving further, here if we observe the triangle ALI and the triangle NBM, can we say both of these triangles are similar to each other? Let's see. Here both of these angles of both the triangles are equal to angle theta. That is, both of these angles are equal to each other. Further, the angle MBN, that is this angle is 90 degree. The angle subtended by the diameter at the point B is 90 degree. And also the angle ALI is also equal to 90 degree. Why? Because I is the incenter and this is inradius. And the inradius makes the angle of 90 degree with the sides of the triangle. Okay, this angle is 90 degree. The sides of the triangle act as a tangent to the incircle. Got it? So both of these angles will be equal to each other and both of these angles is 90 degree. So we got two angles for these triangles are equal to each other. So we can say both of these triangles are similar to each other. And let's apply the properties of the similarities. We got AL upon NB is equal to LI upon BM is equal to AI upon NB. We have used the fundamentals of the similarities. Further, can we say LI into NM is equal to AI into MB? We have cross multiplied these two terms. We got this equation. Now let's move back to our equation, that is AI into BM is equal to R minus G into R plus G. Here can we replace AI into BM with LI into NM? We got our equation as LI into NM is equal to R minus G into R plus G. Here we know Li is equal to small r, that is the inradius, and Nm, that is this distance, is equal to 2 times capital R, that is 2 times the circumradius. Let's replace our terms. We got 2 times capital R into small r is equal to r square minus d square. On solving, we got d is equal to root of r square minus 2 times capital R into small r. This is our formula, that is the distance between incenter and the circumcenter. So we got the formula of d, that is the distance between incenter and the circumcenter, is root of capital R square minus 2 times capital R into small r. This is very important formula. This formula will be used in solving the distance between these 2 points. And the questions are generally asked based on this formula. So that's it for this lecture. Thank you very much for being with Creata Classes. Bye for now.